We're going to go over vertical and horizontal translations of sine waves. Okay? So, we talked about before a sine wave. This is our function for y equals sine x, and we've graphed it on this page. Our major points are at 0 and 0, 90 and 1, 180 and 0, 270, negative 1, and 360 and 0. Those 5 major points give us an entire period of a sine wave. And we know from there we can continue the pattern to figure out what the rest of the values would be on different degrees. Okay? Now remember, our x-axis is measured in degrees, and that's why our values are very high right now. So for your assignment, this lesson is going to come in very handy because we're going to learn how to move a sine wave around the page. Now, if you guys take a look at this function, it looks very similar to something else we talked about. Vertex form, okay? Now, today we're not going to talk about what A does, but we're just going to specifically talk about C and D. No. So, very good question. He said it was reminding him of vertex form and there should be a squared. But it shouldn't be because in vertex form there is no sign of a quadratic, right? There's only a squared, and that tells you it's a quadratic function. This is a sinusoidal function. So the sine gives us this wave, and then these letters, when we replace them with numbers, tell us where to move the wave around the page. Okay? So, to start off, just like in vertex form, we usually call that value of k. Here they call it d. What does d do? Up and down. Up and down. It gives it vertical translations, up and down. So let's talk about some rules for d. If d equals a positive number, which way does d move? Up. Good. And if d is negative? Perfect. So, let's talk about this. Let's do the very first example. Let's say y is equal to sine x plus 2. Okay? There's 2 ways we can go about translating this graph here. We can go to each of the points and move them up. So like we said, we can move those points up 2 units. Or another thing we can do is find the equation of the axis, which in this case runs right through the middle. And we can move the equation of the axis up 2 units. Right? 1, 2. And then redraw the wave from there. What we'll do in this example is, actually we'll move the equation of the axis because I already just did a video about with the points. So, what is the equation of the axis on this graph? It's at 0. So, if we move it up 2 units, how high does it go to? 2, that's right. So let's put it in green here. Our equation of the axis runs right through here. Now we can just take those same coordinates in reference to this. So, this value is on the 2. The next value would be 1 above the equation of the axis, right? Because it was 1 above here. The next value is on the equation of the axis at 180. 270 is 1 below the equation of the axis, so we go 1 below. And 360 is on the equation of the axis. So we've now redrawn our graph. And like we said, we could have just taken each of these points and moved them up 2 units, and it would show us exactly where we are. From there, we can draw the rest of the graph. We know it's going to continue with this pattern. Down, equation of the axis, above equation, on it, and below. Okay? And this graph represents this equation right here. So we've translated it up 2 units. Let's do another one. Or sorry, let's talk about C first. Let's talk about another one. Our C function here. Which way is it going to move the graph? Left and right, or horizontally. Now, this is important here because we talked about it with our quadratic functions. Okay. In the brackets, if the C is a positive value, which direction does it go? Left, okay? And that's when we're specifically talking about in the brackets. And when C is a negative value, it goes to the right. Good. So since we have that, let's make up an equation. We'll say y equals sine x. Now, what I'm not going to do is take a look at our x values. We kind of move by factors of, a scale of 90 in these examples. So I'm going to try to put something that would be easy for us to work with. And in fact, Here's a good one. I'm going to go negative 45 degrees. Okay? So, what does that mean, 45? In terms of our graph, how far is that? Two of our units, or two of our boxes here, are 90. What would one box be? 45. So, for this graph, that means we're going to be moving one space which way? Because it's negative 45. To the right. So we're going to take each of these points and move them one to the right. So at 360, we move one to the right. 270, we move one to the right. 180, one to the right. 90, one to the right. And 0, one to the right. And if we take a look, it's following a very similar or exactly the same pattern. Okay? And all we're doing is moving each of these one box to the right. Okay? So it's making that type of effect, and we know this one's going to go up there. So that's moving at 45. And finally, let's go about doing one last one. Let's say we put both together. So y equals sine. We're going to say x plus 135 minus 1. Okay? So, in words, what's happening to this graph? Okay. Okay, I want to hear, Mark, what is it going on? How far to the left?
45 degrees.
Just 45 degrees?
135.
135 units or degrees. And what's it vertically doing? How far? 1. Okay, and that's from the original one. So we'll do this guy in red. Okay? So what we'll do is we'll first move it along the x-axis. So we'll do the first movement in purple, and we'll do our final one in red. So we'll move on the x-axis first. We're going to the left 135. That can be confusing. Okay? But remember, our scale is 45. So this is 45, 90. 3 units, or 3 of these boxes, is 135. Okay? So we're going to move everything to the left 3 boxes. So 1, 2, 3. 1, 2, 3. Okay? Oh, did I jump one there? I did. Sorry. 1, 2, 3. 1, 2, 3. Oh, sorry, I'm counting from the wrong guy. From the black one is what we're going to be counting from here. So 1, 2, 3. That was right. 1, 2, 3. That was right. 1, 2, 3. 1, 2. Thank you. You guys have much better eyes than I do. 1, 2, 3. Okay. And then we'll do the other one. 1, 2, 3. So it looks like our graph has been moved quite a bit from before. Okay. Now it's starting to look confusing because there's so much else involved here. Okay. That's 3 from this one. 1, 2, 3. Okay. Now, to help myself out here, I'm going to actually do... We're going to do the minus 1 now. So we're going to move the purple graph down 1. Okay, so this guy goes down a unit. He goes down 1. He goes down 1. Down 1. And down 1. And this guy's down. So we'll follow these red dots. And this is the type of effect we're going to get. And if we were to continue that, it would look something like this. Okay, and we continue every single dot, we're getting this type of effect. Okay, so that would be our last one there. So we can't put them all together. It's easier if we do them all on a different graph. That one got a little confusing, but that's the